Hello, my name is Shir and this is a pre-recorded presentation for the 2021 meeting of the Australasian Mathematical Psychology Conference. I'm going to start with some background, I'll describe one of our studies and then summarize the results. So imagine that you're tasked with evaluating some research projects for some sort of philanthropic organization. And your job is to allocate funds to the best project, and you have, in the final round, you have these two projects, one from a molecular biologist and the other from an historian. So the question is, how are you allocating these funds? How are you comparing between these very different projects? Well, perhaps maybe you'll want to use an H-index for the lead investigator, but of course the research outputs and the publishing rates for these domains might be quite different, so H-index might not be as reliable for both of those disciplines. And so in our work, we're interested in this kind of scenario, but in a business context. A lot of large companies are diversified, which means that they have to allocate funds across very different projects. For example, even in an oil an oil company, you might have to allocate between you have to decide to allocate funds between an oil well and a refinery. And while these both have to do with oil, the outputs of each of these projects would be very different and so hard to compare. So what managers usually do in these situations is use financial metrics in order to abstract away from the differences. But these situations have implications financially. One study found, for example, that those that manage portfolios of financially similar businesses are 20% more likely than those managing financially dissimilar businesses to describe themselves as more profitable and faster growing. So if companies just needed to compare between two oil wells, they can use a metric like liters of oil per hour, for example, to measure the efficiency of the well. But without this, companies need to kind of abstract away and use financial metrics, but these may introduce more noise. And maybe this is why we're seeing this kind of pattern in the real world. So one metric of that companies use is called net present value, or NPV. And it's basically just the amount of money that you think the project's going to make, minus the amount of money that you think that you've paid for it already initially. And this is quite popular, as well as internal rate of return, which is pretty much the same thing, just you're interested in the rate of return rather than the net present value. It's the same maths essentially. But even though this allows you to compare across domains, just like H-index, the reliability might vary, and it's unclear if people take that into account. So what has been previously done? In the structural alignment literature, we know that people evaluate options differently based on how easy it is to compare across them. Specifically, options that share metrics are easier to compare. And we also know that when people are given variance information, they often struggle to evaluate or use it. And so this is interesting because it seems intuitive that if, for example, we had a forecast for 20 degrees tomorrow and the confidence was between 19 and 21, you'd have more confidence in that forecaster rather than the one that says 3 to 37. For example. So for our study that I'm going to describe, we were interested in what the effect of how similar a set of projects are to people's use of financial forecast metrics, and we were also interested in how they use any variance information that they were giving to evaluate such projects and allocate resources to them. So the kinds of displays that we gave participants look like the one you're seeing now. You can see 5 different projects, ranking and allocation inputs, some information about the project itself, and then NPV information. So we manipulated a few things in these tables. For one, people either saw 5 projects from the same domain, from the same type of project, or from 5 different ones. We manipulated whether NPV reliability was expressed as words or through numerical ranges, and whether this reliability information indicated that NPV was reliable or not. And then within each display, we manipulated NPV between to be a value between 400 and 900, and critically, we made sure that these values were the inverse of the intrinsic features, such that, for example, the highest NPV project was also the lowest on intrinsic value. And then, of course, as I said, we asked them to rank and allocate, rank the projects and allocate the budget, a hypothetical budget to them. And we recruited from Prolific a sample of US citizens 30 and over, just to get more homogeneous sample and more likelihood of business experience. And we recruited 448 based on a power analysis. So this is an example of a high alignment project set. It's, in this case, made up of oil wells, but of course we counterbalanced with different domains. And so you can see that they all vary on the same metrics, on the same intrinsic features. And in this case, petro yield is the one with the highest intrinsic feature value, and so that one would be the one with the lowest NPV. Here is the low alignment project set, and it's, as you can see, in this case, they all vary on very different intrinsic measures. So the NPVs were either displayed as verbal prompts or ranges, and these were either high or low reliability. So we either literally told them it's reliable or it's not reliable, or we did it using ranges, either really wide or really narrow ranges, 85% or 5%. And by the way, remember this was within subjects. So really, this is as obvious of a range difference as you can make and expect people to notice. We predicted that participants would use the reliability information if it was expressed in words, meaning that when we told them that NPV was reliable, they'd use it, and you'll see a positive correlation between allocation and number of NPV amount. And when we told them that it's not reliable, that they wouldn't use it. So you would see negative correlation between allocation and NPV amount, indicating that they were using the intrinsic features rather than NPV. And for the numerical reliability condition, where they saw the NPV reliability as ranges, we hypothesized no effect because our pilots showed that people really struggle using ranges. Sometimes they use the NPV midpoint, but definitely not using the ranges themselves. So we found results with support for most of our hypotheses. Here you're seeing the allocation data plotted against NPV on the x-axis. So a positive correlation indicates a reliance on NPV, whereas a negative correlation indicates a reliance on intrinsic values, because remember, they're the inverse of each other. We found a significant interaction between reliability amount and NPV in this case, in the verbal reliability high alignment condition. So they saw reliability as words. They were told either reliable or not reliable, and they saw the set of projects being all the same. Okay, so yeah, we found, well, we hypothesized that when we told them that NPV is reliable, they used it, and when we told them it's not reliable, they didn't use it. And at the bottom of the slides, you're going to be seeing the standardized beta coefficient for the interaction in the slide. In the low alignment condition, however, participants still use the reliability information, as is seen by the significant interaction, but if you compare it across to the other alignment condition, so this is just the same two figures as you just saw, but together, we see a significant three-way interaction, meaning that participants were using and relying on NPV more on average in the low alignment condition than in the high alignment condition. In the numerical reliability condition, however, when they saw them as ranges, we saw an effect of NPV amount, but not of reliability amount. So you see that non-significant interaction there, and same in the low alignment condition. And there was no three-way interaction for numerical reliability. Although, as I said, there was a small effect of alignment if you average over reliability amount. Okay, so to conclude, we saw that when reliability was explicit, people used that information to inform their decisions. Meaning that when projects are comparable, they use NPV, and as I said before, they were able to use reliability information when they were given it. When the projects were not comparable, they had to rely on NPV almost solely, although you saw a little bit of leeway with that as well. With numerical information, they just used the midpoint and didn't make use of those ranges in order to moderate their decisions. So first, this supports the structural alignment account and finds some replicating evidence in the domain of financial decision making, and also provides some evidence for variance neglect, of which there is not a lot of work at the moment. People do not use at least range information when they're evaluating forecasts. So it's not clear what the specific prescriptions are at the moment, because it depends a little bit on our assumptions of the real world. So if we want people to use their knowledge of the specific domains to make judgments and not only just use the financial metrics, then diversification in large companies may be a problem. On the other hand, if we want people to use the financial metrics, then the allure of similarity might highlight the intrinsic features more. But either way, both our data and the data that we saw earlier in the presentation of the real world suggest that at the very least, diversification has a cost that we didn't really previously consider. Also, do we want managers to consider the ranges of possible outcomes, or do we want them to rely on the point estimate? Because maybe we consider that that's the best estimate of whatever it is that we're forecasting. So if paying attention to variance is valuable, then we might need to develop better ways of supporting that kind of information in the future. And so that's what we want to do next. And one is we want to replicate this kind of work with managers in real life businesses. We've done this work in this case with lay people, but previous pilot data with Masters of Management students showed very similar results where they use NPV midpoint in their decisions, but not the range information. And also, as I said, we're interested in developing decision aids to help people deal with variance neglect. There's many ways that there's not many ways that this is done, but there's many ways that this might be done. For example, simply by giving people information about ranges and their usefulness, although with some pilot data on this suggests that this is not very useful. But we're also interested in using visual stimuli, or there's also some interesting work done on displays that show the variance information visually by moving different data points around in a dynamic way. So let us know if you're interested in similar issues. But till then, thank you very much for listening, and I hope you enjoy the conference. Here are some references. Contact me if you have any questions. Thank you.